Acha. Let's read the question. The radius vector of a particle varies with time t as r is equals to at 1 minus alpha t, where a is a constant and alpha is a positive vector. Find the velocity v and the acceleration w of the particle as function of time. So out here, the question is saying r, okay, or displacement vector is equals to at into 1 minus alpha t. Okay, if I expand this one, it would be considered as r is equals to at minus a alpha t square. Okay. What is the velocity as a function of time? So we know that v is equals to what? In order to find out the velocity, we need to differentiate this with respect to t. And when you differentiate this with respect to t, it's nothing but a minus 2a alpha t. Okay. The third part is the acceleration vector. A is equals to dv by dt. Okay, so to differentiate this with respect to time, so is equals to 0 minus 2a into alpha. So outer acceleration is equals to constant. We found out the velocity as with respect to time and acceleration with respect to time. Now the second part of the question is the time interval delta t by the principle to return to its initial points and the distance covered during that time. So the position or the particle will return to its initial point when the r vector is equals to or value of r is equals to 0. Okay, that means what? Suppose the particle is starting out here. The initial velocity is in this direction, but the acceleration is always in this direction. Okay, so after a certain time, the particle will go and come back. So when the particle returns to its initial position, suppose at time t is equals to 0, the particle was out here. Okay, at what time will the particle again be at 0? So do you remember AC is equals to ut plus half a t square in projectile motion, where AC is equals to gives the displacement in y-axis. So AC is equals to 0 at 2 points during the initiation of the projectile and during the landing of the projectile. AC in y component. Similar type of concept we apply out here. So when r is equals to 0, we have to find out the time. So using the first equation and putting the value of r is equals to 0. So I can say that 0 is equals to at minus a alpha t square, or 0 is equals to t into a minus a alpha t. So the two values of t are t is equals to 0 or t is equals to 1 by alpha. T is equals to 1 by alpha. So the time taken or delta t is equals to 1 by alpha minus 0, which is equals to 1 by alpha. The time taken, time interval taken out here is equals to nothing but 1 by alpha. Time taken to return to its initial position out here. Okay, and the distance is covered during that time. Out here, make sure that it is asking the distances, not displacement. So how do I find out the distance? See, we must find out the displacement from here to here, and then again add the displacement from here to here. Okay, so out here we need to find out when velocity is equals to 0. When is velocity 0? Why am I finding out this one? Because at the extreme position, the velocity out here would be equals to 0. No, the velocity out this point is equals to 0. So we need to find out this value. This value v is equals to a minus 2 alpha t is equals to 0. So 0 is equals to a minus 2a alpha t. Okay, or t is equals to how much? A and a got cancelled. 1 by 2 alpha. So 1 by 2 alpha is equals to t. So during exactly half time, 1 by 2 alpha, this particle moves from here to here, and 1 by 2 alpha, in 1 by 2 alpha time, this particle moves from here to here. So if we find out the displacement from this position to this position and multiply it by 2, I can get the total distance. So displacement from 0 to 1 by 2 alpha second is equals to how much? I can simply put this value of 1 by 2 alpha out here, because at r is, or at t is equals to 0, r is equals to 0, at t is equals to 1 by 2 alpha. I need to find out the value of r. So r is equals to a into t, 1 by 2 alpha. I'm substituting the value of t with 1 by 2 alpha. Okay, minus a into 1 by, sorry, a into alpha into 1 by 2 alpha whole square. Or the value of r is equals to how much? A by 2 alpha minus a alpha by 4 alpha square. Alpha and alpha would get cut. So r is equals to a by 2 alpha minus a by 4 alpha is equals to a by 4 alpha. Okay. R is equals to a by 4 alpha. So okay, total distance would be twice into r. So total distance is equals to total distance is equals to 2a by 4 alpha, that is equals to a by 2 alpha. Okay. Okay. At the moment t is equals to 0, the particle leaves the origin and moves in a positive direction of the x-axis. Its velocity varies with time. V is equals to v naught 1 plus t by alpha. So out here v is equals to v naught 1 minus t by rho. Okay, out here. Or v is equals to v naught minus v naught t by rho. How do we find out the equation of displacement? So out here, x, to find out the equation of displacement, you can simply use dx by dt is equals to v. You can substitute the v from out here. Okay, or dx by dt is equals to v naught minus v naught t by tau, or dx is equals to v naught minus v naught t by tau into dt. And if we integrate this entire thing, we get the equation of displacement. But x is equals to v naught t minus v naught t square 2 tau into plus some constant. Okay. Now see, using the first line of the question, at t is equals to 0, the particle leaves at the origin. So you understand that at t is equals to 0, the value of x is also equals to 0. Putting these two values in this equation, okay, so at t is equals to 0, or v naught into 0 minus v naught into 0 square by 2 tau is plus constant is equals to 0. So from this equation you get the value of constant is equals to 0. So the equation of displacement comes out to be v naught t minus v naught t square by 2 tau. Okay. So we find the equation of displacement to be v naught t minus v naught t square by 2 tau. Now let's read the first part of the question. The x coordinate of the particle at moments 6, 10 and 20 seconds. So the x coordinate at t is equals to 6 second. So x at 6 second is equals to v naught. What's the value of v naught? 10 centimeter per second. So v naught is 10 into t is 6 minus 10 into 6 square divided by 2. 2 was the value of tau. The value of tau is 5 seconds. So 2 into 5, or x is equals to 60 minus out here 10, 5 to the 10, 5 to the 10 would be 36. So 60 minus 36 is nothing but 24. Okay, so 24 centimeter. Now the next part of the question, at t is equals to 10 second. We apply the same formula, x is equals to 10 into 10 minus 10 into 10 square divided by 2 into 5. So out at 10 and 10 will get cancelled, or x is equals to 100 minus 100. So x is equals to 0 at 10 seconds. So the particle will return back to its initial position at t is equals to 10. Okay. At t is equals to how much? 20 seconds. So x is equals to 10 into 20 minus 10 into 20 square divided by 2 into 5 out here. Our value of x is equals to 200 minus how much? 20 square. 20 square is nothing but 400 is equals to minus of 200. Okay. So it's equals to minus of 200 centimeter. Okay. Now the second part of the question. The moment of time when the particle is at a distance 10 centimeter from the origin. So when is the particle 10 centimeter from the origin? Okay. So x is equals to v naught t minus v naught t square by 2 tau. Okay. So particle is at 10 centimeter from the origin. So out here x is equals to 10, or 10 is equals to 10t minus 10 into t square by 2 into 5. So this 10 and this 10 would get cancelled, or 10 is equals to 10t minus t square. Okay, I have to solve this quadratic equation to find out the value of t. So if we solve this equation, we get t square minus 10t minus 10t plus 10 is equals to 0. So we will use the roots of quadratic equation. T is equals to minus of b plus minus b square minus 10 square minus 4 into a into c. So minus 4 into 10 into c divided by 2a divided by 2 into 1. Or out here, t is equals to 10 plus minus 100 minus 40. 100 minus 40 is nothing but 60 divided by 2. Okay, but t is equals to 10 plus minus 40 can be divided, 60 can be divided as 15 into 4. If I take the 4 outside, it is nothing but t is equals to 10 plus minus 2 root 15 by 2, or t is equals to 5 plus minus root 15 second. Okay, so at t is equals to 5 plus root 15 seconds and t is equals to 5 minus root 15 seconds, the particle will be at 10 centimeter from the origin. Now let's solve the part C part. Okay, the part C part is asking the distance it's covered by the particle during first 4 and 8 seconds. Okay, since it's asking for the distance, okay, remember in projectile motion ds by dt used to give us the displacement vector, no? So you need to find out when is the velocity 0, okay, or the particle is going in this direction, it will return back. Okay, while returning back at the maximum position, velocity was equals to 0, no? So if distance is asked, we cannot simply use ds by dt, because out here the displacement would be, suppose I'm asking at t is equals to 6 seconds. So out here this is not the distance, this is the displacement from the origin. Understood? The displacement will be the distance will be this distance plus this distance. Okay, so you need to find out the time at which the velocity is equals to 0. So v is equals to v naught 1 minus t by tau, or v is equals to 0. If we solve this equation, 0 is equals to v naught 1 minus t by tau, or t is equals to tau The value of tau is equals to 5 seconds. So at t is equals to 5 seconds, the particle will be at this point, or the velocity of the particle will be 0, and it will start reversing in this direction. Okay, t is equals to 5 seconds. Now we need to find out the distance covered by the particle in first 4 seconds. So in the first 4 seconds, the displacement would be same thing, no? So to find out in the first 4 seconds, first 4 seconds, the value of displacement and distance is same, and the value of displacement is nothing but x is equals to v naught t minus v naught t square by 2 tau. These are the equation. So at t is equals to 4, at t is equals to 4, x or distance or displacement, both are the same thing till t is equals to 5 seconds. Okay, is equals to v naught. The value of v naught is 10 into 4 minus 10 into 4 square, or t square, divided by 2 into tau. The value of tau is 5. So 5 into 2 and 10 gets cancelled. Or x is equals to 40 minus 16. 40 minus 16 is nothing but 24. 24. Okay, 24 centimeters. Okay, so this projectile happens at t is equals to 4, which is 24 centimeter. At t is equals to 5, it is some centimeter, and t is equals to 6, the displacement was again 24 centimeter. Okay, and t is equals to 8. So what is the displacement at t is equals to 8? Acha. Can I just say, see, to find out the distance at t is equals to 8, I'm applying a trick out here. The trick is, see, okay, at t is equals to 5 seconds, distance is equals to this much. At t is equals to 8 seconds, the displacement will be this much. So can I find the displacement at t is equals to 8 seconds? So I'm finding out the displacement at t is equals to 8 seconds. So the displacement would be this much. Okay. So if I find out the displacement at t is equals to 5 and multiply it by 2, okay, that will be the total distance, and subtract the value of displacement at 8 seconds. Okay, I'll get this much distance. Understood what I'm doing? All I'm trying to do is I'm calculating the displacement at 5 seconds, that is this one, multiplying it by 2. Okay, I get the total distance, and I'm subtracting the displacement at t is equals to 8 seconds. T is equals to 8 seconds. So all I'm getting is this, the length of this entire path. Understood? So out here, displacement at t is equals to 5 seconds. Displacement at t is equals to 5 seconds. The equation of displacement is nothing but x is equals to v naught t minus v naught t square by 2 into tau. So at t is equals to 5, x is equals to 10 into 5 minus 10 into 5 square by 2 into 5, or it would be 50 minus 25, or is equals to 25 centimeter. So this entire distance is 25, so displacement is 25 centimeter. So the distance covered by the projectile would be 50 centimeter, or 25 into 250. Now I need to find out displacement at t is equals to how much? 8. Displacement at t is equals to 8 seconds. Okay, using the same equation, x is equals to v naught t, 10 into 8 minus 10 into 8 square by 2 into 5. Out at 2 into 5 got cut. So 80 minus 64. 80 minus 64, which is equals to how much? 20. 20 minus 6, 40, or 14 centimeter. or 14 centimeter. Okay, so displacement at t is equals to 8 is equals to 14 centimeter. Okay, so out here, this much is nothing but 14 centimeter. 14 centimeter. Okay, so the entire distance is nothing but 50 minus 40. So total distance is equals to 50 minus 40. Which should be equals to how much is 50 minus 14? 36 centimeter. Understood? So total distance is equals to 36 centimeter. Now the question is draw the approximate plot of ST. So if I draw acha, xt curve, xt curve would be represented by this equation. Okay, what is the equation? By this equation, xt curve, this is nothing but a reverse projectile at t is equals to 0, x is equals to 0, and at t is equals to till 5, the value of x would be somewhat. So if I draw this graph, the graph would look somewhat like this. Okay, at t is equals to 5, the value of t is equals to 5, the value of x is maximum, which is equals to 25 centimeter. Okay, acha. The question is draw the ST graph. Out here, what I've drawn is displacement time graph. If I need to draw the distance time graph, there is a trick out here. Whenever you are drawing distance time graph, okay, from displacement time graph, you can directly apply simple trick out here. This is distance, and out here this is displacement time graph. Displacement time graph can be drawn simply from this equation. Okay, so distance time graph for whatever is the positive part of the displacement that you draw. Okay, wherever the displacement is going backwards. Okay, out here the displacement is backward, no? Out here the displacement is backward. Draw a horizontal line and mirror this curve on that horizontal line. So the curve would look like somewhat like this. Okay, this is the distance time graph. So what I actually did was the graph was like this. I mirrored this part of the graph along this line, and the graph became like this. Okay, let's read this question. The velocity of a particle moving in a positive direction of x-axis, where is as v is equals to alpha into root x, where a is a positive constant. Assume at the moment t is equals to 0, the particle is located at x is equals to 0. Find the time dependence of velocity and acceleration of the particle. That means find the equation of velocity with respect to t and equation of acceleration with respect to t. Out here, equation of v is given with respect to x. So out here, v is equals to alpha into x to the power 1 by 2. Okay, we need to convert this. We need to convert this v with respect to t. How do we convert? Can I write v is nothing but dx by dt is equals to v is equals to alpha into x to the power 1 by 2. Now if I take this equation and this equation and write them separately, or dx by dt is equals to alpha x to the power 1 by 2. I can simply write dx by x to the power 1 by 2 is equals to alpha into dt. I can simply integrate these both, or if I integrate dx by x to the power 1 by 2, acha, x to the power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. This is the integration of dx to the power is equals to alpha into t plus some constant. Okay, or out here x to the power 1 by 2 by 1 by 2. This is the simplification of this term is equals to alpha t plus constant. Okay, or 2x to the power 1 by 2 is equals to alpha t plus constant. Okay, now we know that at t is equals to 0, x is equals to 0. So at t is equals to 0, x is equals to 0. If we input this parameter in this equation, we get 2 into 0 to the power 1 by 2 is equals to 0. Okay, is equals to alpha into 0 plus constant. So the value of constant is nothing but 0. If we solve this, the value of constant is equals to 0. So the value of this constant is equals to 0. So our equation becomes 2x to the power 1 by 2 or 2 root x 2 into root x is equals to alpha into t. 2 into root x is equals to alpha into t, or t is equals to 2 root x by alpha. Okay, t is equals to 2 root x by alpha. Okay, so out here the value of t, acha, the value of t is how much? T is equals to 2 root x. Acha, I did not need to find out the value of t. I need to find out the value of x, or root x is equals to at by 2, or x is equals to alpha square t square by 4. Okay, alpha square t square by 4. Now v is equals to dx by dt, or if you differentiate this equation with respect to t, we get the value of v, or v is equals to alpha square into 2t by 4, or is equals to alpha square t by 2. This is the value of v, or v is equals to alpha square t by 2. Okay, so after we found out the value of v, now we need to find out the value of acceleration. We know that acceleration is equals to dv by dt. Okay, or a is equals to alpha square by 2. Now let's move at the third part of the question. The mean velocity of the particle averaged over the time that the particle takes to cover the first s meters of the path. That means the question is asking find the average velocity. Average velocity for the first s meters. So average velocity is equals to total displacement divided by total time. Total time. So total displacement is equals to how much s? Acha. To get the equation of time, we need to find out the value of x. X is equals to alpha square t square by 4. Okay, this is the equation of displacement. So if we substitute s out here, or s is equals to alpha square t square by 4, or if we find out the value 4s by alpha square is equals to t square, or 2 under root s by alpha is equals to t. Okay, so out here the value of t, okay, the particle will cover the distance s in t is equals to 2 under root s by alpha. So out here time is equals to 2 under root s by alpha. So average velocity, okay, is equals to s divided by 2 under root s into alpha, or is equals to, would cut out this under root s. So alpha into under root s by 2. So let's read this question. A point moves rectilinearly with deceleration whose modulus depends on velocity v. of the particle as acceleration is equals to a root v. This w is nothing but acceleration in irodov, and a is nothing but a constant, where v is the velocity. Where a is a positive constant. At initial moment, when the velocity of the point is equals to 0, that means what is given? The boundary condition is given. That means at t is equals to 0, t is equals to 0 second, v is equals to v naught. Okay, what distance will it travel before it stops? So when does the particle stop? The particle stops when v is equals to 0 or velocity becomes 0. What time it will take to cover that distance? So what is the distance covered before it stops? So let's start with the equation. We are given with deceleration, deceleration or negative of acceleration is equals to a root v, where a is a constant. Acha. We know that acceleration is equals to dv by dt, which can also be written as v dv by dt. This can also be written as v dv by dx. Okay, out here. See, we all know how this formula came, v dv by dx. I'll just show you in a little bit concise manner. See, v is equals to dx by dt. Okay, and a is equals to dv by dt. So when you divide a divided by v, or 1, this is 2. When 2 divided by 1, we get a by v is equals to dv by dx, or a is equals to v dv by dx. This is the origin of this formula, v dv by dx. Okay. This was some additional information which was not required in problem solving. So let's get back to the problem itself. So the first problem, the first thing that tells us is deceleration is equals to minus a dot v. So deceleration is equals to or minus v minus v or minus v dv by dx is equals to how much? A under root v. Why? Because this is deceleration, negative of acceleration, where acceleration is equals to v dv by dx. So out here, can I simply write minus v dv by root v? Why root v? I took this root v to the left hand side, is equals to a, where a is a constant, or minus root v dv is equals to a dx. A dx. I forgot to take this dx to the right hand side. Okay, we have to take this dx to the right hand side. A dx. So when we integrate this, integration of root v dv is nothing but minus v to the power 1 by 2 plus 1 divided by 1 by 2 plus 1. Okay, is equals to a x plus some constant. Okay, out here minus v to the power 3 by 2 divided by 3 by 2 is equals to ax plus some constant, or minus v to the power 3 by 2 into 2 by 3 is equals to ax plus some constant. Okay, so out here minus 2 by 3 v to the power 3 by 2 is equals to ax plus some constant out here. Okay. At initial moment, the velocity of the point is equals to v naught. That means what? When the distance was equals to 0, that means this condition also says that at t is equals to 0, x is equals to 0.
Okay, v is equals to v naught. So when you apply that boundary condition at x is equals to 0, v is equals to v naught. Okay, so out here minus 2 v naught to the power 3 by 2 divided by 3 is equals to constant. So when you apply the constant in this equation, we get minus 2v to the power 3 by 2 divided by 3 is equals to ax minus 2v naught to the power 3 by 2 divided by 3. Now the question is saying what distance will it travel before it stops. So when does the particle stops? The particle stops when v is equals to 0. The particle stops when v is equals to 0. See what I did. From till now what I did was I created a negative acceleration, then I wrote out the equation, then I made a equation. This is nothing but indefinite integral. Okay, for definite integral you put the limits out here. For indefinite integral you put a additional value of constant and find out the value of constant using boundary condition given in the question. Okay, so out here the boundary condition was at x is equals to 0, v is equals to v naught. So I found out the value of constant using those boundary condition, and then I substituted the value of constant in the original equation, and I got this equation. Now in the main equation of velocity versus x, what was given in the question? The question was given the distance it travels before it stops. So I know when the particle stops, v is equals to 0. So the question is essentially asking what is the value of x when this v is equals to 0. Understood? So out here this entire term will become 0. 0 is equals to ax minus 2v naught 3 by 2 by 3, or a, sorry, x, not a, x is equals to 2v naught 3 by 2 divided by 3 into a. This is the value of x. All of you understood this one. The next part of the question was what time it will take to cover that distance. Okay, so I simply can write the second part of the equation minus dv by dt is equals to a under root of v, or minus dv by root v is equals to a dt, or minus, what is the integration of 1 by root v? Nothing but v to the power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1 is equals to at plus some constant. Okay, so out here minus v to the power 1 by 2 divided by 1 by 2 is equals to 80 plus some constant, or is equals to minus 2v, or minus 2 root v is equals to 80 plus some constant. Okay, now what was our boundary condition? Our boundary condition was at t is equals to 0, v is equals to v naught. See, at initial moment, that means at t is equals to 0, v is equals to v naught. So out here if we solve this one, minus 2 under root v naught is equals to constant. Now when you apply the value of constant in this entire equation, we get our equation to be minus 2 root v is equals to 80 plus or minus 2 root v naught. Now the question is saying what time it will take to cover the distance before it stops. That means what is the time taken when the velocity v is equals to 0. Okay, so I simply substitute v is equals to 0 out here. Okay, or 0 is equals to 80 minus 2 root v naught, or t is equals to 2 root v naught by a. So this is the time taken before it stops. Okay, let's read the next part of the question. A radius vector of point A relative to the origin varies as t is equals to r ati minus bt square j, where a and b are position constant. I and j are unit vectors along x and y axis. So what is this actually? This is nothing but the displacement vector given in terms of ati and bt square j, or displacement position vector. The equation of point trajectory y is equals to x and plot this function. So again we have to do the same thing. We have to plot, or we have to make y as a function of x and eliminate the parameter of time out here. So out here, see, r is equals to, or position vector is equals to ati minus bt square j. So this nothing out here is the x component of movement, x component, and out here nothing but, this is nothing but the y component of displacement, or displacement position. So out here the x axis can be given by at and y axis can be given by minus bt square. So from this one, can I replace t is equals to x by a, and can I put this t in this equation? So if I put t in this equation, I'll get y is equals to, or y is equals to minus b t square, or x by a whole square, or y is equals to minus bx square by a. Acha. How do I plot this function? This function is nothing but a inverse parabola. See, have you learned quadratic equation? When the coefficient of a is negative, what kind of graph do we get? We get this kind of graph. Okay, this is y, this is x. Okay, this was our part A of the question. Now part B of the question is saying, find the time dependence of velocity and acceleration vectors as well as the modulus of these components. So what part B is asking is, find the equation of velocity. Velocity is nothing but dr by dt. Okay, is nothing but d into at by dt I plus d into minus bt square by dt j, or velocity vector is nothing but ai minus 2btj. This is the velocity vector. The modulus of velocity vector would be nothing but v modulus is equals to magnitude of this vector. Magnitude of any vector is x square plus y square, or is equals to a square plus minus 2bt whole square under root. Okay, or modulus of velocity vector is nothing but a square plus 4b square t square under root. Now the second part of the question is, find the acceleration vector. Acceleration is vector is nothing but dvx, or velocity of x component of velocity I. X component of velocity is nothing but this one, and y component of velocity is nothing but this one, plus vy by dt j. Or what is the x component of velocity? X component of velocity is nothing but 0, plus dy by dt. Dy by dt is nothing but y component of velocity, or minus 2b d by dt j. So acceleration is nothing but minus 2b j. Okay, out here this is the component of acceleration, and the magnitude of acceleration would be nothing but minus 2b out here. Okay, I'm sorry, the magnitude of acceleration there would be no minus, this would be only 2b. The magnitude of acceleration is only 2b out here. Part C of the question. The time dependence of angle alpha between the vector W and V. Whenever time dependence is asked, that means we need to find out the vector dot product. That means vector dot product means acha, the vectors between acceleration and A dot V. A dot V is nothing but magnitude of A into magnitude of V into cos of theta, where theta is the angle between V and A. Out here, instead of giving theta, they have given out the value of alpha. See, so out here instead of theta, we'll write with alpha. Okay, or out here, cos alpha can be given as A dot V divided by magnitude of A into magnitude of V. So out here, what is A dot V? A dot V is nothing but when you multiply I with I, there is no component of I, so I component will be 0. When you multiply j by j, it is nothing but, see, when you multiply this component by this component, it will be nothing but 4b square t, and j dot j is nothing but 1. So a dot v, a vector dot v vector is nothing but 4b square t, or cos alpha is equals to 4b square t divided by, what is the magnitude of a? Magnitude of a is nothing but 2. What is the magnitude of b? Magnitude of v is nothing but under root of a square plus 4 pt 4b square t square, 4b square t square. Okay, so or cos alpha is equals to this 2 b and b, 2 and 2 get cancelled. Cos alpha is equals to 2bt divided by under root of a square plus 4b square t square. This is our equation of alpha. Now the key might be given as tan alpha, but what we have found out here is cos alpha. So how do I convert cos alpha into tan alpha? See out here. Let's draw a trigonometry. This is 90. Let's say this is alpha. So what is cos alpha? Cos alpha is nothing but base by hypotenuse. So it's nothing but 2bt by under root of a square plus 4b square t square. Okay. So what is this perpendicular? By Pythagoras theorem, hypotenuse square minus base square is equals to perpendicular. Why? Perpendicular square plus base square is equals to hypotenuse square. So if you do this one, a square plus 4b square t square under root whole square minus 2bt whole square is nothing but a. So our perpendicular would come as a. So this equation, this cos alpha 2bt by a square plus 4b square t square under root can also be written as this triangle. So if cos alpha is equals to this by this, tan alpha is equals to a by 2bt. So out here you can even write tan alpha is equals to a by 2bt. Okay. Check out the fourth part of the question. Okay. What does the fourth part of the question say? The mean velocity vector averaged over the first t second of motion and the modulus of this vector. Acha. Whenever any mean of thing is asked, mean means average, is nothing but v dt divided by dt. So what do I mean by that? See, suppose there is a function. Suppose I'm plotting a graph of y and x, and the graph comes up to be something like this. And I'm asking what is the mean of y from x is equals to 1 to x is equals to x2. So mean of y is nothing but y dt, sorry, y dx divided by dx. Okay, or area under this curve divided by this length of this line. Understood? This will give us the average value of y out here. So simply, See, if I find out the average value of velocity with respect to time, what do I get? V dt divided by dt. Understood? So out here, velocity velocity vector is given as ai minus 2btj. Okay, so the average of velocity vector in x component, see, in x component will always remain same as a in y component. However, I have to find out this one. So average of velocity vector is nothing but ai minus 2btj into dt divided by dt. Okay, from 0 to t, from 0 to t. See, if we integrate this one, at from 0 to t minus 2b t square by 2 from 0 to t divided by t from 0 to t. Okay. Out here this is I, out here this is j. Or this will be nothing but at minus bt square divided by t. Or this is nothing but a minus bt. Or this will be nothing but v is equals to a minus bt. Okay, I almost forgot to put the value of I cap and j cap out here. I cap and j cap out here. Now the next part of the question is find the magnitude of this modulus. Acha, what is the magnitude? Magnitude of average velocity is nothing but a square plus b square t square under root y, because this component square a square minus bt square is nothing but b square t square. Okay, so let's read this question out here. Okay, a point moves in a plane xy according to the law x is equals to 80 and y is equals to 80 1 minus alpha t, where a and alpha are positive constants and t is time. Asha. That means the x component of equation with respect to time is given by this one and y component of equation with respect to time is given as this one. The question is asking find the equation of point trajectory yx and plot this function. That means find the position of y with respect to x. That means whenever I'm finding y as a function of x, that should be independent of time. And how do we do it? We write those two equations. X is equals to 80. This is the equation number 1. Our equation number 2 is y is equals to 80 1 minus alpha t. Okay, or y is equals to 80 minus a alpha t square. Okay, and we substitute the value of t in either of the equation out here. X by a is equals to t, y, see, x is equals to 80 if I send the a to the left hand side, so x by a is equals to t. Now can I substitute this t out here and out here? So if I substitute this t out in these both places, what do I get? Y is equals to a into x by a minus a alpha x by a whole square. If I elongate this, what will come out? Y is equals to x minus alpha x square by a. This is our equation of trajectory, or y as a function of x. Y as a function of x. There is no parameter of time in this equation. All of you understood this one? So out here, the second part of the question is plot this function. Okay. The next part of the question is we have to plot this function. Okay. So how do I plot this function? Y is equals to x minus alpha x square by a. This is nothing but the equation of a parabola. And how do I plot it? The equation will look like a straight line. See out here. At x is equals to 0, what's the value of y? At x is equals to 0, the value of y is equals to 0. So out here, the line would be inverse something. Okay, this is y-axis, this is x-axis. Okay. Part B of the question. Part B of the question is find the velocity v and the acceleration w of the point as a function of time. Okay. So what are the velocities? The velocities are is nothing but dx by dt, or rate of change of position x component of position in I, plus dy by dt j. This is the formula for velocity. Velocity vector is dx by dt I plus dy by dt j. Okay. Or out here, x is equals to 80. X is equals to 80. So out here dx by dt is nothing but a ai, or v vector is equals to ai plus what is dy by dt? What happens when we differentiate this with respect to time? Is nothing but a minus 2a alpha t. Is nothing but a minus 2a alpha t j. Okay, this is our component of velocity. 2 part B, find the acceleration vector. Acceleration vector is nothing but rate of change of velocity in x component by dt I plus rate of change of velocity in y component by j. Sorry, this is not by dt j. Okay, so what is dx by I? This is nothing but when you differentiate this with respect to t, we get 0 because this a is a constant out here, is equals to 0 plus what happens when we differentiate this with respect to t? We get minus 2a alpha. So minus 2a alpha j. Okay, our acceleration vector is equals to minus 2a alpha j. Okay, the third part of the question, the moment time t naught in which velocity vector forms an angle pi by 4 with the acceleration vector. So whenever angle between two vectors are given, what do? We always form dot product or vector dot product. Okay, let's see in the next question. Let's in the next slide. So how do we form vector dot product between v and a? So let's see. We simply use v dot a is equals to magnitude of v into magnitude of a into cos theta. Or out here, cos theta is equals to v dot a divided by magnitude of v into magnitude of a. Out here, theta is equals to pi by 4. Okay, and we need to find out the value of v dot a and magnitude of v and magnitude of a. So let's find out first v dot a. So 3 part a, find out v dot a. So v dot a is nothing but ai plus a minus 2a alpha tj dot into minus 2a alpha j. So out here, I will be multiplied by 0 and j would be multiplied by j. So out here, this is nothing but minus 2a alpha a minus 2a alpha t, j into j becomes 1. Okay. What is the magnitude of v? 3 b. Magnitude of v is nothing but a square plus a minus 2a alpha t whole square under root. This is the magnitude of v. And what is the magnitude of a? The magnitude of a is nothing but 2a alpha. Why? The a acceleration exists only in y component. See out here. Okay, so the magnitude of acceleration is nothing but this one. So when you substitute these values, this value, this value, and this value into this equation, what do we get? So let's pull this equation out here. I'm pulling this equation out here. Okay, so cos theta or cos pi by 4, cos pi by 4 is equals to v dot a. What is v dot a? V dot a is nothing but minus 2a alpha a minus 2a alpha t. So minus 2a alpha into a minus 2a alpha t divided by what is the magnitude of v? The magnitude of v is nothing but a square plus a minus 2a alpha t. So a square plus a minus 2a alpha t whole square. Okay, into what is the magnitude of a? Magnitude of a is nothing but 2a alpha. So out here this and this would get cancelled. So out here cos pi by 4 is nothing but cos 45, and cos 45 is nothing but 1 by root 2. So 1 by root 2 is equals to a minus a minus 2a alpha t divided by under root of a square plus a minus 2a alpha t whole square. Okay, and we solve this entire equation on the next slide. Now when we solve this equation by cross multiplying, what do we get? See, I just cross multiply this parameter with this one and this parameter with this one. Okay, so what do I get? I get under root of a square plus a minus 2a alpha t whole square into minus of root 2 into a minus 2a alpha t. Now what do? I square both left hand side and right hand side. Square. So I get a square plus a minus 2a alpha t whole square is equals to 2 into a minus 2a alpha t whole square. Okay, so if I solve this one, I get an equation such as 2. See, if I send this entire term to the right hand side, what do I get? 2 this parameter minus this parameter. So I get a square is equals to a minus 2a alpha t whole square. What I did out here was I took this entire parameter and subtracted from this parameter. See, 2 into this entire term square minus this entire term square is nothing equals to this entire term square, and a square was kept as a square. Now if I take a square also to the left hand side, the equation would become a minus 2a alpha t whole square minus a square is equals to 0. Now can I write this equation as a minus b, a square minus b square? So if I write this equation as a square minus b square, what will be? The equation will be a minus 2a alpha t plus a into a minus 2a alpha t minus a is equals to 0. So out here there are two roots of this equation. This one, first root will be coming from this one and the second root will be coming from this one. So let's take the first root. Okay, first root. So a plus a. is nothing but 2a minus 2a alpha t is equals to 0. Okay, or out here 1 minus alpha t is equals to 0, or t is equals to 1 by alpha. T is equals to 1 by alpha. Now let's take the second root. Second root, a and a would get cancelled. So minus 2a alpha t is equals to 0, or t is equals to 0. So at t is equals to 0 and t is equals to 1 by alpha, would get the angle between velocity vector and acceleration vector to be 45 degree. Okay,